So to develop a project network, we need to get some information together about the activities and what activities precede other activities. And ultimately, we're going to create a chart that depicts the sequence of these activities, their start and finish times, the resources eventually that will be required for those activities, and ultimately we'll be able to use this to identify the critical path of the project network. We'll be able to use the project network to do scheduling. We'll be able to use it as a communication tool. It'll allow us to figure out roughly how long the project will take, where we'll need cache resources available for activities, ultimately identify what activities are important or critical, and use that as a management tool to keep the project from being delayed. And so the project network is one of many tools that managers can use to keep the project on plan and hopefully within budget. We're going to use the example from Chapter 4, the work breakdown structure, that was for the computer prototype. And in the computer prototype work breakdown structure, we had one of our elements was the creation of the circuit board. And within the creation of the circuit board, several organizational units were responsible. The testing people had some testing. The design folks were going to do some design work. The production folks were going to build the prototypes. And the software folks were going to do their software work. So you can see that we've got an overlay of the organizational units and the work breakdown structure. And we'll worry about both of those at some point. But right now we just want to figure out how this all fits together and what order these activities need to be put in so that we can actually deliver the deliverable of the circuit board. So what you can see here in this project network is that we need to first take care of the specifications and documentation activities. Once we do that, we can, in parallel, build our first prototype and then have our software group take care of the software. And then after that, we can go ahead and build our final prototype. And then after that, we can finalize the software. And after that, we can test. And once we've done all these activities, we can actually deliver the circuit board to the rest of the project. I know when I just described that project network, I threw out some terminology that you're not familiar with yet. And so the next few slides, we're going to talk about what all these words mean. So let's start with the words here. An activity, which we'll throw around a lot, is that lowest element on the project network that requires time. It's something you can assign equipment and people to and track it, know when it starts, know when it's done. So that's that lowest element. We sometimes have merge activities in which several activities need to be completed so we can proceed or move forward. An example of that is shown right there. A and B merge into D. And also notice that we've got parallel activities represented on this particular project network. A and B, if you have the right resources, can run in parallel. They both can be completed at the same time by different individuals. And then D can get started and C can get started if, again, you have the resources to do D and C in parallel. Some additional terminology. We use the word path to define a sequence of connected and dependent activities. And then we define the critical path, which I've used a few times already in class, but here's the official definition. It's the longest path through the activity network that allows for the completion of all project-related activities. It's also the shortest expected time in which the entire project can be completed. Also, we call that the early finish time. Delays in any activity on the critical path will delay the entire project. A few more words here on terminology. We sometimes use the word event to describe a point in time when activity is started or completed, but does not consume time. So, again, we'll use the event. The beginning of an activity is as the event, and we sometimes think of milestones as being events. When a certain activity gets completed or started, we'll earmark or identify a certain point in the project in which something good has happened. We use the term burst activity to identify an activity that has one or more activities immediately following it, and or you might think of it as one or more activities that are dependent upon it to be completed. The example is shown here. where A is a burst activity, and A needs to be completed before we can start all the other activities beyond A. Within our project network terminology, we're going to see two approaches in the book, but we're going to use only one. We sometimes see activity on nodes, where we'll actually write the activities on nodes, and all these networks you've seen so far are activity on node examples. Some operations management, supply chain management books use activity on arrow. We'll leave those alone for the other disciplines that use that. Most project managers and most people that deal with project networks deal with the activity on node. All right, so we have some terminology completed. Let's take a look at what the other rules are for creating project networks. We will typically have networks flowing from left to right. It's not like a computer flow chart that you usually see going from top to bottom. We cannot begin another activity until anything preceding it that's connected to it is completed. So if an arrow is drawn to it, there's a relationship between that activity and the activities preceding it. Arrows indicate precedence and flow and can cross over each other. So it's not as structured as computer programming flowcharting, for those familiar with that. So you can have crossovers. Again, looking at the SIM project, Microsoft Project Network, you'll see some pretty complicated things going on there. It's desirable for each activity to have a unique identifying number, and that the further along in the project network you get, the numbers get greater. Sometimes that's not easy to do, but that's a desired thing to have. We can't loop back. No turning around. Project flows from left to right. And usually looping occurs because you created some conditional statements, and so to avoid that, conditional statements are not allowed. There is no uncertainty allowed within the project network. That's why sometimes this form of project planning doesn't lend itself for highly uncertain projects, where you have lots of conditionals or things that you need to resolve before the project can be successful. So those conditional statements are covered more by risk analysis, and we'll get to talk about those pretty soon. And last thing, if you've got lots of activities that roll up to end the project or that need to be started at the same time for the project to officially come to start, you use a common start and stop nodes on your project network. All right, you've got some terminology and some rules down. So let's see if we can create a project network with this example right here. My suggestion is you look at this particular chart and see if you can draw the project network. I'm going to show that on the next slide, of course. But take a look at what's going on here verbally before we actually try and draw something. For this project, we got to have an application approval happen before we can do the construction plan, traffic study, or the service check. The staff report can be written after the construction plan and the traffic study are done. And the commission approval report, the commission approval can occur once activities B, C, and D are done. So let's take a look at what that looks like on the next screen. Initially, we start out with our application approval. Once that's completed, we can now go into a burst activity of doing the construction plans, the traffic study, and the service check availability. Now we can see that we've included the commission approval and staff report and drawn in the predecessors and the dependencies there. Have a waiting time for the construction. We put that in there, and then once the staff report and the building's actually built, we can actually occupy the building. All right, so now that we've recreated the network logic, we have to go back and put in the duration for the individual activities so that we can do some analysis of the network. What we'll be able to do once we put in those durations is do a forward pass, which will tell us how early activities can start, how early they can finish, and how soon the project can be done. And then taking that information and then running a backwards pass, we'll be able to figure out the latest times. How late can activities start? How late will they finish? And then ultimately, which activities are on the critical path, and where's our slack or float where we can delay activities without delaying the overall project. Going back to our original example, we've included activity times for all of the particular activities in this project network, and you can see that lots of the stuff is paperwork type activities, so that you don't expect a lot of duration. And of course, the longest activity is actually letting the building be built. It takes about a half a year. So we'll go ahead and create a slightly different looking project network. It will look the same in terms of logic, but we'll include some additional formatting, and you'll see that on the next slide. Here's the project network from before, but we've added a few things to the individual activities. We've added spaces for the early start and early finish, the late start and late finish. We'll calculate the slack, that's what SL stands for. And what we've done initially is put the duration, the DUR, in that middle lower box. We've also put the description of the activities in each activity box. So with this information, we can now figure out through a forward pass how exactly how long this project will take. And so what we'll do is we'll put a 0 in the upper left-hand corner in activity A, indicating that we're going to start the project on day 0. We'll add 5 to it, and in the upper right-hand corner, based on that, the early finish time for activity A will be 5 days. Hopefully everyone's following that. Since A is a burst activity, we'll take that 5, and from that, if the application approval process takes a full 5 days, the earliest we'll be able to start the next activity is at the end of day 5. So we'll put the 5 in the upper left-hand corner for activities D, C, and B, as shown on the next slide. Let's take a look at what actually occurred here now. So we've taken the 5 days in activity A and moved it to the early start times for D, C, and B. And then in every single case, we've added the duration of that activity to the 5 days initially out of activity A, and made that the early finish time for each individual activity. So you can see that B, the early finish time will be 20 days. C, the early finish time is 15. D, the early finish time is 10. So now we have to make a decision. If you have 2 arrows going to an activity with 2 different durations, you always in the forward pass take the largest number. So going to activity E is 20 days coming out of B and 15 days coming out of C. So we'll put 20 in the upper left-hand corner for the early start time for activity E. And that merge activity, activity F, we have 20 days coming out of B, 15 days coming out of C, and 10 days coming out of D. We'll go ahead and put 20 days in there. And we'll continue on through the network, taking the early start time, adding the duration, getting the early finish time for each activity, and then moving forward through the network till we get to activity H, in this particular case, occupancy. The project will take 235 days to complete. That is the early finish time for the project. So here's the trick before we start the backwards pass. We always set the early finish time equal to the late finish time, assuming we want to get this project done as soon as possible, and that will set us on the course for our backwards pass. And now instead of adding duration, we'll start subtracting. But before